So we're doing video 3 of unit 4, and we're talking about mean absolute deviation. It is a measure of variation that indicates how the data varies or differs from the mean. So our first step is to find the mean. And we know we add all these numbers up and then we divide by how many numbers there are. So we have, when we add all these numbers up, it ends up being 540. And then we would divide by 9. And that will equal 60. So our next step is to find the distance, or the absolute value, between the mean and each value in the data set. So we're going to do that on the next board. So since our mean was 60, we're going to figure out how much each number is away from 60. So first you would subtract 60 from each one of these numbers. And when I subtract 60 from each one of these numbers, I will get these values here. So 2, 4, 3, 11, -8, -7, and 1. Now, if you notice, some of these numbers are negative. These numbers here would be what we call the deviation. And this is the actual distance away it is away from the mean, which is 60. But we must find the absolute value of these numbers, and we know that the absolute value is always going to be positive. So that means these numbers, whether they're negative or positive, will always be positive. Now we're going to add all of these numbers up and then divide by how many numbers there are. So and this will equal 38. And then we do 38 divided by 9, and that equals 4.2. So what this means is that our mean absolute deviation from 60, either way, will be 4.2. All right, so we're going to look at another example here. So we have these values here on these two charts, and we're going to find the mean of each one. So we would add all of our values up here, and this would have a mean of 6, and this one would have a mean of 5. Now, when we do our mean absolute deviation, so since our mean is 6, this is 2 away from 6, this is 1 away from 6, and these are 1 away from 6. So we're going to add up these values here. So we have 2 plus 1 plus 1 plus 1 plus 1, and that will give us 6. And then we're going to divide by 8. For those of you who missed what I just did, what I did was I calculated how much each value is away from our mean, which is 6. So we know that 4 is 2 away from 6. We know that 5 is 1 away from 6, and that 7 is 1 away from 6. But there are 3 7s here, so that's why I put a 1 for each one. And this will then reduce to 3/4. All right, so for this one, our mean is 5. So 3 is 2 away from 5. 4 is 1 away from 5. 6 is 1 away from 5. And 7 is 2 away from 5. And when we add all of these up, we should get 12. And we're going to divide by 8 because there are 8 values up here. And that will give us a mean absolute deviation of 1.5. All right, so we're going to use a real life example for for this, you are choosing a restaurant to eat at with your friends. Olive Garden has a wait time of 50 minutes with a MAD deviation of 10 minutes. TGI Fridays has a wait time of 40 minutes with a MAD of 20 minutes. Which should you choose and why? So we're going to start with Olive Garden. And Olive Garden had a 50-minute wait with a MAD of 10 minutes. And TGI Fridays had a MAD of 40 they had a wait time of 40 minutes with a MAD of 20 minutes. So if you notice here, there is a 20-minute overlap. Now you just have to decide which restaurant you want to eat at. Now we see with Olive Garden, we have a wait time of 50 minutes, but with the MAD being 10 minutes, that means we could get in earlier at 40 minutes, get in 10 minutes earlier with 40 minutes, or we have to wait a little 10 minutes longer, and it will be an hour wait. Whereas TGI Fridays, they're saying we have a wait time of 40 minutes, but we have a MAD of 20 minutes, which means that we could get in 20 minutes earlier and eat within 20 minutes, or we may have to wait an extra 20 minutes and it may be an hour. So this is a real life example of MAD. Yay, turn up.